Okay, guys, I'm back with part 5 of the Eastern Cape September 2023 paper 2. So, guys, if you're watching this for the first time, please make sure that you see all my parts, you see everything, guys. You don't get lost. Everything is on here. It's on this. So when you see part 5, it means that there's part 4, there's part 3, there's part 2, there's part 1. So go and check them out, okay? So please make sure, I'm going to emphasize this, that guys, share my videos with everyone who is doing grade 12 that you might know. Just share with them so that they can also benefit from this free knowledge, okay? So let's get on to part number 5. Okay, part 5. This is the part 5, which is the last part for the Eastern Cape paper number 2, September 2023. 5.1. The life science teacher is doing a research on bees. He focuses mainly on the three kind of honeybees, namely the worker bee, I think this is okay. Yeah, mainly the worker bee, queen bee, and the drone bee. I don't know what is the drone bee, but I think I have a knowledge about the worker bee and the queen bee. Oh, I think I know all of them. The workers are the ones that collects honey, and the drone bee, these are the security guys. You know, when I was still young back in my village, I used to go with my brother to collect honey during winter. So I have experience of these things. They will teach you a lesson, these things. So the queen bee is the queen bee, doesn't go out. This one doesn't go out. So the ones that goes out to collect honey is the worker bee and the drone bee. These are the security guys. You see these ones, this one they will bite you. This one they don't play, because these they are guarding. When these ones they go and collect, these ones they are busy, they guarding the honey. Okay, as part of his research, he builds a scale model of the honey bees belt. Okay, on Annexure D is a picture of the model he built. Okay, so let's go to that and see them. Let's go and see those honeys. Let's go and see those bees. They are, there they are. We have the worker. I don't know how they are different, but on this here, it shows that this one is the smallest, and the biggest is the drone here. The drone, I think, is bigger than the queen. You see? Yeah. So the labeling there is fine. Everything is fine. There's no other information that we can get here. But let's go back to the question. They say a queen bee is approximately 2 centimeter in length. The length of the teacher's model is 23 inches. Show that the model that the teacher built is 29 times bigger than the actual bee. So you can't compare the inches with the centimeters. One needs to be converted. Which one do you convert? You must convert the inches. Okay. So we are given the relationship not between the inches and the millimeters, not the inches and the centimeters. So it means that we need to convert what? This. Okay, we can convert. Let me see which one we can convert. We can convert 23 inches into the millimeters. Then thereafter we convert it into the centimeters. Yes. So we can say 0,5 inches is equals to 12,7 millimeters. Then we cross multiply. We're going to have 23 inches, which is equals to a question mark. Then we cross multiply. Then we're going to say 0,5 question mark is equals to, so we're going to have 12,7 multiplied by 23, which gives us 292,1. Then we divide both sides by 0,5. We divide both sides by 0,5. Then we are left with the question mark. And that gives us 584,9 2 millimeters. Therefore we multiply, we don't multiply, we divide here by 10 to get the centimeters. Divide by 10, and then that will give us 58,442 centimeters. Okay, then let's go up here. So this 58,42, it is what? It is the length of the teacher's model in centimeters. Therefore, let's check how many times does the size of the bee goes. Then we divide by 2 centimeters. Divide by 2. I think I divided twice. 58,42 divided by 2. Give us exactly 29,21 in that order. So because they are decimals there, then now when we round it off, it's gonna be 29 times. Now they say write down the ratio scale for this enlargement. So we know that 229,2 so we're gonna say 58,42 is to 2. Okay, so what else now are we going to do? Now we're going to say, and remember that is the ratio, so we're going to say the 52 is the length of the teacher's model, and then the 2 is the size of the bee. Okay, so now what are we going to do? This is messlet. We look for the smallest number, then we divide both sides by the smallest number, then we divide by 2, we divide here by 2, so that will be 1 is to 29,21. Okay, then we go to the next one, 5.12. They say a honeybee, a honeybee flies at an average speed of 24 kilometers per hour. Its wings beat 200 times per second. Let me do this. Let me remove this, because already they are recorded. You can just rewind the video, but let me just remove this and also here so that I can be able to see here. Now, a honeybee flies at an average speed of 24 kilometers per hour, and its wings beat 200 times per second, causing their distinguished bees. You see, when they move this, show by means of calculation that the bee wings will beat 300,000 times if it flew 10 kilometers. Remember, I want to give you something. The bee, for 1 hour, it will travel 24 kilometers. But listen to this. The bee, for 1 second, it will beat what? It will have 200 wing beats. Cross multiplication. Mr. Cross multiplication. You see that? So now, what will we need? You see, it's 5 marks there. It's 5 marks. So we need to know, okay, how many times does a bee wings beat in 1 minute? We don't know that, but we can get it. Remember, 1 minute is the same as 60 seconds. Is the same as 60 seconds. You see that? So question mark, cross multiply. So we can have the question mark as 200 multiplied by 60. That is equals to 12,000. This is 12,000. This 12,000. 12,000 what? Wing beats. It means that in 1 minute, remember 60 seconds is the same as 1 minute. Okay, so in 1 minute, let me do it. In 1 minute, the bee will wing 12,000. The bee will do 12,000 wing beats. But now, in 1 hour, the bee will do how many wing beats? Cross multiply. 1 hour is the same as what? 60 minutes. Cross multiply. Okay, so we're gonna have 12,000 multiplied by 60, which is equals to, which our question mark now becomes 720,000. Now let's go back up there. This is the wing beats, right? It means now we have just now solved this. We now know that for 24 kilometers per hour in 1 hour, remember that thing means that in 1 hour the bee will travel for 24 kilometers. That in that 24 kilometers the bee will have 720 wing beats. Now they want to know how many. They want us to prove that indeed in 10 kilometers the bee will beat 300 times. Look at the cross multiplication. Let me write this side now. Remember, the 1 hour is for 24 kilometers. It means that in 24 kilometers, the bee will do a wing beat of 720,000. Okay, so now we need to know how many wing beats will be in 10 kilometers. Cross multiply. So we're gonna have 24 question mark is equals to 720 multiplied by 10. That will be 7,200,000. Then the other zero doesn't want to fit. I'm going to put it there. Then we divide both sides by 24. Then our question mark is going to be divide by 24. And it gives us 300,000. For me to know math lit, guys, it took me a varsity actually. In high school, yes, I was doing well, but it took me a varsity to master the math lit like this. But I can give you the tricks of math lit. You just need to understand English, but you don't need to understand a deep English whereby you just have to talk bombastic words. Here in math lit, there's no bombastic words. Okay, there is I can say a very lame English here, a very low standard English. But if you can understand the structure of a sentence, then you will understand the message. Let's go to 5.2. Landscaping gurus. Oh, these people, they're copying from me. This one shows the top view of a botanical garden in the shape of a trapezium. There is a circular water tank with a diameter of 1.5 meter in the garden. There is the tank, then those are the dimensions. Let's go. Let's go to the questions. Must not take time rounding. The first question says, calculate the perimeter of the potential garden. What is the perimeter? The total distance around the object. This is the object. Now we talk about the garden. So in the context, we're going to say this is the total distance around the garden. So we don't count this. This is not the diameter. This doesn't count for the diameter. When you talk about the diameter, we talk about this distance around the garden. So we're going to have 12 meters plus 5 5.5 meters plus 6 meters plus 5.5 meters. So how much is it? Oh, I don't know what happened to my handwriting there. I don't know, because it's like I'm flying. Let me not fly. So the perimeter is equals to 12 meters plus 5.5 meters plus 6 meters plus 5.5 meters, which is equals to 12 plus 5.5 plus 6 plus 5.5, which is equals to 29 meters. Then we are done. Then we go to the next question. The next question says, determine the area taken up by the vegetable garden excluding the water tank. Yo, Kosia. Amara is a small water. The small water. So we're going to divide that garden. So when you look at this, we see what? A triangle. When you look at this, we see what? A triangle. So there are two triangles with the same dimensions, because if you look at this, the perpendicular side, we see 5.5. But what is the height? What is the height of this triangle? Because this becomes our base. This is going to be the base. How much is our base? How much is our height? So our height is going to be 4 meters, because where do we see it? Is here. So how much is our base? So we're going to do this. Our base, remember, from here to here is 12. So what are we going to do? We're going to say 12 minus 6. It means from here to here plus from here to here is going to be another 6. Therefore, we divide that 6 by 2. It means this is 3, this is 3, this is 6. So all in all is 12. Understand? So we're going to start by calculating the area of what? Area of triangle. So which is half base times height. So we're going to have, how many triangles do we have? We have 2. So we're going to multiply here by 2. We're going to have 1 over 2 multiplied by, what is our base? 3 multiplied by, what is our height? 4. Then we multiply by 2. Then how much is the area of that? So 1 over 2 multiplied by 3 multiplied by 4 multiplied by 2. So it gives me 12 meter squared. Like that. Good. Then now we go to the area of this, the rectangle. So let's go and do it. Area of rectangle. So this area of rectangle, I'm just going to immediately subtract the area of that circle. So we're going to say minus area of a circle. So it's going to be length times breadth, close brackets, minus pi r squared. So what is our length? Our length is 6. Our width is 4. Close brackets, minus 3,142 into brackets. What is our radius? Because our diameter is 1,5. Therefore, radius is equals to 1,5 divided by 2. 1,5 divided by 2, it is equals to 0,75. 0,75 meter then squared. So this is going to be 6 multiplied by 4 is going to be 24 meters squared. 24 meters squared minus, let's go and do that one on the calculator. We're going to start by saying 0,75 to the power 2. It gives us 0,5625. Then multiply by 3,142. It gives me 1,7 1.7 meter squared. So that is going to be 24 minus 1.77, which is equals to 22.23 meter squared. Therefore, the area of the garden now, area of the garden is equals to 12 meter squared plus 22.23 meter squared. Remember, the area of that circle is already subtracted to that side. So that will be how much? This thing. Yo, it almost closed this. Plus 12 plus 22.23, that is equals to 34.23 meter squared, like that. Let's go to 5.3. Any question you have, just comment and I'll take you through. I thought I'm almost done. There's 5.2.3. They say the volume, they say the volume of the water tank is 8.84 centimeter cubic. Calculate the height of the circular water tank, round off to the nearest meters. They want us to calculate the height of the tank, and from doing that we also need to take that volume into the meters. Okay, sharp. Here are two things that are different here. Yes, the volume is given in in centimeter cubic, but when you look at the area of the tank is given in meters. So there is something that needs to be converted. Okay, let me do this first. Do you see the formula? I'm interested in the formula. Let me write the formula just here. The formula says volume is equals to pi r squared multiplied by height. I want to manipulate this formula because right now, from this formula, they want us to calculate a height, not a volume. So what am I going to do? I'm going to create this triangle to cheat this formula. So I'm going to have a divide here. I'm going to have a multiply here. So I'm going to have to take these two. And because this is a multiply, I'm going to put pi r squared here. And I'm going to put height. Then I'm going to put a volume. So now what do we need? Let me do the highlight. What do we need? We need the height. So if we need the height, what is it that we see? We see that height is equals to volume over pi r squared. That's how I understand mislead. I make mislead look simple because it's simple. Okay. So now, if you look at the volume is given in centimeter cubic. But already this pi r squared, this already we have it. How much is it? It's 1.77 meter squared. Do you see that the two have different units? So Ash, I'm going to teach you something here. Oh, there's an errata here. Because I was going to show you something else. Okay, so there's an errata here. Let me open that errata so that you guys can see it. Let me just zoom in. I also don't see. Let me just zoom it in. Where is it? already here, the learners in Eastern Cape here, I think they got the marks, because they say in the question paper the units for measurement of the water tank was presented as cubic centimeters, meaning that those units were supposed to be in the cubic in in the cubic meters, meaning that, let me show you the why am I going here? Let me show you the correct one here. It was not supposed to be centimeter, it was supposed to be meter squared. So in a simplest form, that means we're going to take the volume of 8,84 meter cubic divide by what was this, the pi r squared, the area of that circle. It was 1,77 meter squared. So when we do that, is 8,84 divided by 1,77, which now gives us 4,99. Did they say we must round off? Yeah, they say we must round off to the nearest meter. So that means the height here is 5 meters. Height is 5 meters. So this is the power of knowing how to manipulate a formula in maths lit. It's powerful, eh? It's powerful. 5.3. And I want to remind people that I do the house calls. You call me and I come, because there's a reason why I do the house calls. Because here on the, when I do the online classes, I tend not to teach to my best. You understand? Because someone, when they're at their own space looking at the computer and you're talking to them, they won't understand the same way, but they have different charges. I charge differently, so there I have to talk to your parent so that they will understand what is it that I'm coming from. Remember, they know better for your future. Okay, so if you really want me to teach you face to face, I do the face to face. Okay, so I am located in Johannesburg South. Okay, just staying here next to Southgate at Naturen. Okay, so if you need the one-on-one, I'm available. I'll just put you on my schedule and tell you what time we can meet up. So when I do the house calls, I normally do 4 to 5 hours, so that when I leave there, I leave you with a lot of information. Okay, so that next time you don't have to call me again, you will know what to do in maths lit. Okay, right, let's continue. 5.3. Add a function, a helium balloon with the number of seats was attached to each chair. There were 60 red balloons, 240 white balloons, and 260 pink balloons. Inside 10% of the pink balloons was a piece of a paper in the shape of a heart. Each learner whose chair had a pink balloon attached to it received a free rose. But a helium balloon is a balloon that is filled with helium and rise into the air if not held. Oh, okay. The following tree diagram was drawn to simplify the information. So we can see the balloons. A, we don't know what is that. Red, white, pink, 60, 240, 260. And then pink, because they are heart and no heart. So they say, determine the number of balloons at each of the letters. A, how many balloons are there in all? So we're going to say A is equals to 60 plus 240 plus 360. How much is it? 60 plus 240 plus 360, and that is 606. So we have 660 balloons. And then B, how many pink balloons have a heart? So B is equals to 360 multiplied by 10%. Remember, they've said it on top there that 10% of the pink balloons was a piece of a paper in the shape of a heart. So we're gonna say 360 multiplied by 10 over 100. 10 over 100. So how many are they? They are only 36. And then C, the pink balloons that don't have a heart. So we're gonna say 360 minus 36. So how many are they? 360 minus 36. They are minus 36. So they are 324. Therefore, you got your 5 marks. Write down the probability of randomly selecting a balloon that has a heart-shaped paper in it. So the probability is that it's only 36 out of 360 balloons. They didn't tell you how to write your probability in a percentage or as a decimal, so you leave it as a fraction like that. So 5.3.2, determine the probability of receiving a free rose in simplified fraction format. Okay, probability of receiving a free rose. Remember, they say, what are the chances that you will be given a free rose? They say each learner whose chair had a pink balloon. How many pink balloons are there? If the pink balloon, there are 360, we know that we have 360 chairs that has a pink balloon out of 660 chairs. So they say the answer should be in a simplified ratio form. So you go, in the fraction form, you go to your calculator, you just say 360 divided by 660, and that will give you 6 out of 11. You almost did the same thing. So this brings us to the end of part 5 of Eastern Cape September 2023 paper 2. So guys, thank you for watching this up to this far. I love you guys. I hope that you do well in your matric year or wherever that you are watching from. I wish you the best.